Okay, so today's lesson that I was supposed to teach you, but snow days happen, is 1.4. So you should be taking notes with me. This is how this works. Just like if I were there with you, staring at you, right? We should all be facing forward, taking notes, following the instructions, behaving. Just like if I were here. Okay, so title. So 1.4. Title is distributive property. Okay, what this means. Hopefully we can see it. We'll push focus real quick. Make sure you can see that. Okay. Now, so to distribute, right? Let's talk about this. Distributing means what operation? Think about it. What operation do we use when we distribute? Anyone have an answer? Think about it. Anyone gonna say it out loud even though I can't hear you? The answer is multiplication. Right? Multiplication is the key for this one. Now, when we distribute, there's usually parentheses around something and then a number out front, right? This number out front is the thing we are distributing. Distributing means put it with anything that's on the inside. Could it also look like this? We could have parentheses. Could our number also be in the back? Could that still work? Is this still multiplication? Just like that one. Yes. Could this still be distributed even though it's like it looks backwards? The answer is yes, right? Okay. So, basic distributing. First kind of easy examples and then we'll talk about some more stuff, right? So, basic example. Let's have 5 out front, parentheses, x plus 6. Close your parentheses. Again, we have the 5. We're going to take it and draw a little arrow, say we're going to distribute. When we distribute, we already decided we use multiplication. So we're going to say, hey, 5 times x. Can we take 5 and actually multiply it by the letter x? No, so we leave it together, just 5x. And then 5 is positive, 6 is positive. What is 5 times 6? It is 30, right? And so since it's positive, we put plus 30. And that's it. Yes? Okay. I'm going to give you 2 examples. How about x minus 4, close it. How about a 7 on the back? Try that one. Same kind of thing. Number is just in a weird spot, right? Okay, again, distribute. Pay attention to your signs. 7 times x. Positive 7 times negative 4 is negative. What's 7 times 4? 28. Did you get the same answer as I did? Right? Okay. Now, last one before we move on to anything else. How much of a difference does it make if I put a negative and then a 4? Parentheses. I'm going to change it up a little bit. What about 5x minus 6? So I put a negative with my number out front, and there's now a number with my variable. Does this change our method at all? No, it does not, right? So we're still going to say, hey, we're distributing. When we distribute, we multiply numbers with numbers. So a negative 4 times a 5, that's a negative 20. Since this has the x, this has an x, this doesn't, we still have an x. Now this, negative 4 times negative 6, what's a negative times a negative? A positive, yeah. And then 4 times 6 is 24. And then we're done, right? Nothing else we can do right now. Okay. Do we get that before we move on? If not, you can ask, and I'm sure we can come up with some more examples. Okay? Okay, I'm going to switch boards. Okay, now we have a couple of vocabularies to talk about. First thing we're going to talk about is combining like terms. What does it mean to combine like terms? Think about it. Anyone want to tell your substitute teacher if you know what it means to combine like terms? Just like if I were there. Anybody at all? Okay. Whether or not you got this right, I hope somebody knew. This would be great to see if we remembered. Okay, combining like terms means they have to have the same exact variable, and put S in parentheses because it'd be variable or variables depending on what they've got going on, and amount of them, or amount of variables. Right? What we mean from this. Example, if I have 4x and I'll put comma and 5x squared, are those like terms? Look at them. Both have numbers. They both have x's. But are they like terms? No, they're not like terms. They're not like terms. Why? How many x's does this guy have? He only has one x, x to the first power. You just don't see the 1 there. This guy, how many x's does he have? 2. Since they're not the same amount of variables, ending part of our definition, they are not like terms. And we want like terms so we can combine them, which means we want to add or subtract them. These are basic operations, okay? Next definition is simplest form. Okay, what this means, it means all kinds of things. First, our final answer has no parentheses, right? Because that means we could have distributed something. That's why we have our order of operations. Parentheses comes first. That's why we get rid of it. Or like terms. Because if they have like terms, we can add them together. So that's what we are going to do. We're going to do all different kinds of examples. We're going to look at them, and we're going to combine them together or not, and then see what we can do, okay? So let's start with an easy one, okay? Let's see. Number 1, 17u plus 15u. That's our expression we have. Now you ask yourself, do they have like terms? Right? So that means, do they have the same ending? Do they have the same kind of variable? Yes or no? The answer is yes, right? They both have a u and they both only have one u, right? That means we can actually take these numbers and do what it says. So positive 17 plus 15. So we do, hey, what is 17 plus 15? Right? So we do the math. What is 17 plus 15? Anybody know? Anyone say it out loud? 30. What? 2? Is it 32? I think so. And then what do they both have? A U, so we need to have a U on it because we added them because they're like terms. Okay, so you only have one U. The U is what made them special, so that's why it still has a U. Okay? We're going to do more. We'll make them a little bigger, okay? I'm going to switch boards and erase this one. Let me give you another problem. How about this guy, number 2? Markers are always dying. How about 6t squared plus 3t minus 1t? Okay. Look at them. They all have t's, right? But like terms means you have to have the same amount of t's. So look here. This has t squared. Does anything else here have a t squared? No. So he's all alone, right? We can't do anything with him. He's alone. I'm going to rewrite. I'm going to grab another marker. I'm going to rewrite him because we couldn't do anything with him. Now, these both have t's on them. Only one. So are they like terms? Yes. Okay. If they are, so we're going to have something with a t on it. So then we do the math. Positive 3 minus 1. So what is 3 minus 1? Positive 2. So we just combine these, added them together. Is there anything left over? Okay. Now how we check? If it's in simplest form, right? First question, is there any parentheses left over? Nope, not at all, Miss Rinaldi. Okay. Next, are there any other like terms? So we only have 2 terms. Look at them. Are these alike? Could we add them, or are their amount of t's different? Nope, their amount of t's are different, right? This has a 2. This doesn't have a little squared on it either. So since they're different, this is the final answer. Okay. Let's try another one. 6n subtract 4n. Can you all do this on your own? Do it on your own real quick. Write your answer down. Give it a little bit. We'll see if we get all the same answer, okay? Okay. Are they like terms? I think they are. This is my final answer. Did you get the same final answer? Hope you're nodding your heads or something. Tell me that you got the same final answer. I wish I could see it. Okay, let's try a harder one, okay? Number 4. 4y to the third plus 2y subtract 8y plus 5. There you go. There's 4 numbers in there. 4 terms. Remember we learned the word terms? There's 4 different terms here. Look and see if they have anything in common. I always just start left, right, and go, this guy. Does he have anything in common? If not, I write him down. Look in this one, if you have anything in common. All right, so start there. You can do it. I believe in you. Try it out. I'll get a drink of water while you do that. I'll slowly write my answer. Did you get the same answer as I did? Do you see how my arrows show what didn't have anything in common and then underline the stuff that had something in common so we could add them together? Right, make sure you keep the signs with whatever is with it, right? You can't just forget about the signs that go with each number. Okay, I'm just going to slide this up. What about this problem? This one's a different problem. B squared plus 13b plus 13. That's crooked. But anything different about this? Can we simplify this guy? Yes, no, maybe so. Do you see anything they have in common? No, I don't see anything they have in common either, right? This has two b's, b squared. This one only has a b. This has no b's at all, right? That's just a number. Since these have nothing in common, right? I'd just rewrite them basically, right? So it's the same thing we had. If you have a problem where nothing can be combined like terms, you just write the answer simplified. You just say, hey, Miss Rinaldi, it's already done. For me, it's good. It's solid. 100% great. Ready to go. Feeling good. 5 is ready. Okay? So check them first, but this can be an answer because it is already done for us. It was just being really polite. Okay? Now we're going to take our two thoughts of distributing and combining like terms, and we're going to mix them together, okay? Like so. What if I gave you this guy? Parentheses. 5m plus 2m parentheses 10, see where it's at, plus m squared. Okay? Now, looking at this problem, remember, think back to what our order of operations tells us to do. That may help you out. What are we going to do first? It's really up to you. There's multiple ways we can do this, right? We have this 10 out here, which really means this 10 is being multiplied. You can always put it in parentheses too. So you see it looks like a 10. So technically this 10 is being multiplied by all of this, so we could distribute first. We could do that. Or we could use orders operations and add them together. What are you guys thinking? What do we want to do? I would practice my order of operations, right? So we can get those down. Order of operations tells me to look on the inside of the parentheses first and go, hey, can we add those things together? Can we simplify this? 5m plus 2m. Can we combine those like terms? Are they like terms? Say yes, Mr. Rinaldi, they are. So 5m plus 2m turns into 7m, right? So this is just all added together. That means times 10. We still have times 10 there. Then at the end, we have plus m squared. Again, our order of operations tell us to do what next? Please excuse exponents. We can't really do anything with that exponent, right? Because it's not a whole number, okay? My dear, multiplication, division. Do we have any multiplication or division? Multiplication. 10 times 7m. With multiplication, you can multiply things that are different. So 10 times 7 is 70m. That had an m. We didn't do anything with this. Bring it down. And then we ask ourselves, Does this need simplified? Are there any parentheses left over? No. Are these like terms? Can we simplify this anymore? We go, no, Miss Rinaldi. Then we are done. Now, if we would have distributed first, we'd still get the same answer. So that's the cool thing about the math, or all math, right? Sometimes there's more than one way to do it, but you'll still get the same answer. Okay, let's try another. I'll move this board. Okay, this is number 7. How about, looking for one. How about 6 parentheses 2g squared plus 9g minus 3? This one's got a lot of stuff in the middle, right? All kinds of stuff. What do you think you'd want to do first? You said order operations. You could look at it and go, huh, can we add any of these together? Are these like terms? No. Are any of these like terms? No, they're not. They are not at all. When there's more than 2 terms inside the parentheses, I would always just go back to, hey, distributing. So we take this 6, multiplying by each whole number that is inside the parentheses. So 6 times 2 is 12. Keep the g squared. 6 times 9, or 9 times 6, depending on how you would like to say it, is 54. Add a g. And then 6 times negative 3 is negative 18. So now we look at it. After we distributed, we have already figured this out. Can you add any of these together, or is it already simplified? If we already thought about it up here, we already know it is already simplified and we're ready to go. Done. That was it. Right? We just have to see. Okay? Now I'm going to do something crazy. You ready? I'm going to make it real crazy going on. How about 7 parentheses a squared plus b, close it, minus 4, parentheses, oh, I'm getting real fancy now, a squared plus b. Now, what do you notice? You notice we have 2 sets of parentheses. That means we're going to have to potentially distribute twice, right? Because in here, can we actually add anything together? No. So we're going to have to distribute this 7 times everything in here. Now I have a question. What numbers are in front of these letters if there's no number written there? What number's there? 1, right? Technically the number 1 is just slid on in there. So those are the numbers we multiply by. So just start in the front. 7 times 1 is still 7, and we have the a squared. 7 times 1, again, 7, but now we have a b, right? Now this one, are we going to multiply with the 4? We're just going to take the 4, or are we going to have to take that negative with it? Think about it. Is this just 4, or is that negative a part of that 4? Pretty sure that negative is a part of that 4, right? So when we distribute, we're going to have to take that negative with the 4, just like we did before. Again, there's 1s inside, right in front of those numbers. So negative 4 times 1 is negative 4, and then a squared. Negative 4 times 1 again, negative 4, and then b. Now I get 4 different terms. So start from the beginning. A squared, a squared. Anything else have an a squared on? Ooh, this does. Everything that's in front of it, look. That's an a squared, that's an a squared. So we can add those numbers together. So what is 7 minus 4? Or 7 plus negative 4? They mean the same thing. What is 7 and negative 4 added together? It is 3. Since we're combining like terms, we keep the a squared, because that's how we knew to look at them. Then this one, we got that has a B. Look, this also has a B. Again, a positive 7 and a negative 4. That's positive 7 and negative 4 added together. We get positive 3b. So we just went from this really long equation to 2 little terms, right? Always good to focus and pay attention on it, right? Always, always good. Okay? Okay. Let me move boards. I need my third board. Okay. Next, I'm gotta give you another vocabulary word. Next word is coefficient. Right? Okay. A coefficient, right, is a number that is attached to a term. So it's part of a term, so a set of numbers, right? Period. Example. I'm just going to go on with that, and I figure that's enough. 6xy. 6 is the coefficient because it's the number. This is one term. Because a term, remember we learned this in the first section, is something connected by multiplication, whether it's numbers or variables. It's the number in the term. Now, so 6 is our term. If we had this example, though, if I said 7x squared, what's our term? There's two numbers now. We have a 7 and a 2. Think about it. This 2, what did we call this when we were taking our notes? We called this what? A power, right? Or an exponent. That's not the same thing, right? Our term, our coefficient, I wrote term. Our coefficient is always the whole number, the big number, not the exponent, right? It's always a big number. It could be a fraction. This could be 1/7 if we really wanted it to be, right? I could change this if I was feeling fancy. 1/7 x, that would still be my coefficient for this problem, okay? Because it's the number attached to its term. This 2 is an exponent, not a number, not a whole number, okay? Okay. Now, let's do some review. Since you have a quiz coming up, right? It was supposed to be today, but we didn't have school yesterday, which I bet you were all thrilled about, right? Bet you were. Let's flip. I'm going to flip to a practice quiz. Must be after this section. There it is. Okay. We're just going to practice some of the things we have learned, okay? Let's start. We'll just label it, if you want, practice problems. Okay, number 1. I'm telling you, these are your instructions. Write a verbal expression for each algebraic expression. So write a verbal expression for each algebraic expression. Remember, a verbal expression is the same thing as saying write a sentence. We'll put it in sentence form. Okay, so I'm going to write this. 21, a subtraction sign, a x, and a 3 in the exponent spot. So that is the algebra version, right? That's an expression. I want you to write it as a sentence, as a verbal expression. Take a few moments. Think about it. Remember, 21, you can just write 21. You can just write exactly how it is. Think about how it is written, okay? I will let you think while I erase these boards. Think back to your words that mean the same thing as your operations. Okay. We're thinking. You got it? Almost? I'm just going to slowly write it. Remember, there are lots of answers. That is one of many answers you could write for this one. Anyone have something different they would like to share? And see if you guys agree. Remember, you could use take away. You use less than, but if we use the word less than, our order is going to be a little funky. You can use the word the difference of, right? We can also use to the third power instead of cubed, or the power of 3. They mean the same thing. I use the shortest way possible without using the M word, without using minus, right? Which is fine. I just don't like it. You can do whatever you want, right? As long as it's appropriate for this and it is one of the rules. Okay. How about we try another? How about this guy? You're going to have a fraction. On top, let's say your number is 45. On the bottom, let's say the bells are still on while I'm recording this. On the bottom, let's say your answer is A with a 4 in the exponent spot. How about that one? Try that one for a couple. Okay. You got something? I'm going to give you a real basic one. You ready? 45. Oh, little arrow. 45 over A to the, don't fall asleep, 4th power. That's my basic one. 45 over A to the 4th power. Remember, you could also do the quotient of, and then said 45 and A to the 4th power. Or you could have said 45 divided by A to the 4th power, right? Lots of options. right? Don't forget to look at those because we're not going to have our charts when we take our test, right? Okay, you got this? If not, she can pause it for you. I'm going to erase it, and we're going to do order of operations. It says, the title says, evaluate each expression. That means find the answer, okay? Number 3, 24, division sign, 3, subtract 2 times 3. Remember that dot does mean multiplication, right? It's not a decimal, ladies and gentlemen. You know who I'm talking to. Okay, that's a real simple one. Try that one first. Give you a hint, the answer is a single digit. Order of operations. Remember, please excuse my dear Aunt Sally. Aunt Sally, she's a nice lady. I'll give you a couple of these. Okay, I give you 3 problems. The first one is a single digit answer. The second one is also a single digit answer. That is bracket 5 divided by parentheses 3 times 1, close your parentheses, close your bracket, 3/5. The last one's the doozy. This one is a fraction. On the top, you got 40, subtract 2 to the 3rd power. On the bottom, in the denominator, you have 4 plus 3 times, in parentheses, 2 to the 2nd power. Make sure you're paying attention. All of them are actually single-digit answers. Okay? I'm going to pause it and let you write it and try them. I'm going to write my answers. Okay, while you're doing this, I will show you the problem's answers in a little bit. When you're ready, if you look at these and you don't get the same answers as me, or if you guys are confused, I would stop. And we'll work on these. You and your sub, we can work on them on the board, okay? So don't be discouraged. You can do it. You probably did something just really simple. I did not show my work on these because of how close they are together. I did just write the answers. Okay, and I'll double check them right now while you guys keep working. Yep. Okay. I checked them. They're all the same answers I got before. I'm going to show them to you now. So if they're not ready, I would pause this because I'm about to push the unfreeze button. Okay. There's my answers. Again, if we are confused, remember inside out for parentheses, top then bottom, then divide at the end for fractions. Work on them together. Okay. Last bit. We are going to practice what you had last night. I'm going to erase that. And that is your, surprised you can't see all that. Those are the property ones, okay? Remember, additive identity, additive inverse, and then multiplication. I just call it multiplication. Multiplication identity, multiplication property of 0, multiplication inverse, and then you have reflexive, commutative, associative, symmetric substitution. Okay? Let's write some down. Remember, you're going to have to find out what x is, then write which property it is. Remember, the operations are used most of the time. It helps you figure out which ones they are. Okay? So let's just start out. Let's say I have okay, let's do x, right? Because that's what they always are. How about x plus 0 equals x. Oops, am I supposed to give you an answer for x, wasn't I? 5. So first off, can we figure out what our answer for x is? Yeah, it's 5. Okay. Now, which operation did we use? We used addition, right? Okay. Now, what property, or think of the word to use? We used addition. We added 5 to 0 to get itself. What's it called when we use addition and we get itself back? What are those words? It is additive I think I spelled it wrong. It's for sure spelled wrong. No, it's not. Okay. Identity. I just for some reason thought it was extra T. Right? Additive identity, because you're adding to nothing and getting yourself back. Okay. Number 2. How about this guy? X times 1 equals 3. First off, what's x equal? You should write it down. Well, we should technically write it down here, right? First off, what's x equal? Okay, 3 it is. Next, what operation are we using? Does it make a difference? Using multiplication. If we're using multiplication, it does make a difference, right? We're multiplying by 1 to get itself. So we got 3. We had 3, we multiplied by 1, and we got 3 again, we got itself. What's that called? No, the word's hard to say, so we can abbreviate it. Just call it multiplication or mult. Identity. Is this coming back? Hope so, even with a day off. Number 3. What if I say x plus 6 equals 5 plus 6? This has more stuff in it than just... Remember, the addition properties have 0 in them. They have the number 0 in them every time, right? Like this one has 0, the other one has 0 in it. So if you see addition but doesn't have 0 in it and it's got more numbers in it, then it's not the addition properties, it's one of the other properties, okay? So then you first go, okay, what is x? That's the easy part, right? Now you say this side, if the 5 were actually there, it would say 5 plus 6 equals 5 plus 6. So it's exactly the same on both sides. What means when you look at it, it's exactly the same. Like when you look at yourself, you're exactly the same in the mirror. That was a big hint. Which one's this one? You can just write that word. You don't have to put the property word. That is the correct one. Yeah? Remembering? Okay. About number 4. Okay, how about x plus 3 equals 3 plus 5. Throwing you off now. Think about it. What's x going to be? That's the easy part. This says 3 plus something. Well, this one says 3 plus 5. So that means x has to be 5. Okay, now again, this has addition in it, but it's got more numbers, no zeros. So it's got to be a different rule. What does it mean where you have something, your final answer is the same thing, but flipped? Flipped it. Like you cut it down in the middle, now it's flipped. That's kind of hard. This one's one of the last one we learned. This one is commutative. Again, property is the correct word afterwards. Remember that one? These ones will be the hard ones. The add and multiplying ones are not actually the hard ones. Okay, number 5. How about this guy? 8 times x equals 1. It's multiplication, so it's got to be multiplication property. Think about x times what? I mean, 8 times what makes 1? Think about your properties. The goal is to try to do this without your notes. If you need to look back, it's okay. But remember, on our quiz day now that we're going to have on Monday, and then on our test day that we're going to have this Friday, next Friday. Without everything worked out, you're not going to get these notes. So it's good to know them. Multiplication something. Can you figure out what x is? It's multiplication something. X is 1/8. Multiply by something, get yourself. You multiply by your inverse. Does that come back to you? I hope it was. I hope someone already said, duh, Miss Rinaldi, and you're just looking at me, looking at my video like I'm crazy while I'm saying this. I hope that's the case, since I can't be there in person. Okay, I'm going to scoot that. I'm going to do some more, because we're not done, right? Number 6, how about this guy? 5x equals 5 times 3. How about that? That's a property. What does x equal? That's the easy part. What's that called when we take this side? Exactly the same. We just plugged in that number for that. We use multiplication. Multiplication is the only time we plug something else in for something else. What's that called when we plug something in? What's a fancy math word? It is substitution. I hope someone said it out loud. Substitution. Yay! Okay. What else do we have left? Ooh, this one. X times 0 equals, I can't do that. It really doesn't matter. Three times 0 equals what? What does 3 times 0 equal? Answer, 0. What property tells us anything times 0 equals 0? It's the multiplication. This is a long one. Property of 0. Right? Anything we did not do? I think, we didn't do associative. Remember associative? We're about running out of time. Associative property looks like this. Remember? So if I have A plus 6 plus 5, and I put parentheses around A plus 6, equals 4 plus 6 plus 5 with parentheses around 6 plus 5. The order of the numbers are the same, but who I associated with was different. The parentheses are different. That's why it's called associative. And then A would be 4 in this case. That's the last property. Okay, make sure you do your homework. Make sure you look over it. If you have any questions, you can email me. I will let you ask me any questions and stuff beforehand. I won't just throw you into a quiz on Monday. I'm not that cruel. I promise. It just depends on the day and how bad you are. Okay? I'm just kidding. Well, depending on who you are. So please be good. Please do your homework. And I will see you guys on Monday.